Hi everyone, my name is Elias Zuno, and I'm going to be here to talk to you about zoonotic diseases. So this first article I went into is from the EFSA, the European Food and Safety Authority. They basically handle, obviously, like food safety, but mainly, specifically in this article, is talking about foodborne illnesses through zoonotic diseases. So I guess first we can ask is what is a zoonotic disease? So a zoonotic disease is a category of diseases that is mainly transmitted through animals. This can vary through varied consumptions of like food and water that is contaminated by a pathogen, such as like bacteria, viruses, and like parasites. Mainly through the body, like in the gastrointestinal tract, where like the first symptoms start occurring. And one of like the most common foodborne illnesses that you see is usually from like Salmonella, Yersinia, um, E. coli, Listeria, Campylobacter. Probably one of like the most significant ones that you can relate to is Salmonella, because we always like handle eggs and chicken, whatever you're cooking in the kitchen. Um, you should know that when you're handling these poultry products properly, you would like want to wash your hands and scrub the surfaces after you're done cooking. Now, these foodborne illnesses have been like a widespread public health threat for like a while. In the European Union, over like 350,000 human cases are reported each year. And there's just a lot of like advances in technologies and detection, but there's just a lot of stages that you'd have to hurdle through in order to like detect these pathogens, especially like in the food. It could be like contaminated at the farm level, where like animals where they're eating, it could be like a lot infested with bacteria, or even like parasites could be in like their food source. That's why it's always super important to know where your food is coming from, do some background checks and research on the products you buy. Did you see any articles written about them that like maybe there was a contamination at this date? Then also during maybe like where there's slaughter, where the meat can be contaminated through like intestinal contents. There's just some cross contamination. Their methods weren't done correctly, where now then you have this meat that's contaminated essentially. And then you go through the hurdle of the processing stages where the people may be handling the food incorrectly when they're packaging. And then the last step was when customers receive their product, are they preparing their food properly during their cooking stages? Like, are you cleaning the surfaces you're cleaning on or you're cooking on, or is your food properly cooked all the way? And what I've spoken to about before, like just this whole process of when a pathogen is able to transfer itself from non-human species over into a human species, which sometimes causing illness or death. And it makes itself this infectious presence that is what's called zoonosis. And that term isn't really thrown around a lot, um, but it does help clear up the complexities behind all these headlines that you've seen in maybe our lifetimes, like the swine flu, bird flu, SARS, and now even COVID-19. What makes them so complex and hard to detect and cure is the fact that they're able to jump around from different species of animals. You can never really fully isolate it into one species, because as soon as you think you have it, it has already jumped into another species. And then we can, as a counterexample, let's say smallpox was as like naturally occurring, and it was only ever really able to infect human hosts. But except in like laboratory conditions, when they were doing for like vaccine research, they would experimentally like infect like non-human primates and other animals. And because of this, in like 1980, the World Health Organization, the WHO, were able to completely eradicate the smallpox because it wasn't able to jump around. It wasn't able to hide from us, essentially. And then another example, the polio virus, which we developed a vaccine for, and now reduced significantly by like 99%. And this was accomplished because just um, apart from infecting humans, The poliovirus just had nowhere to hide. It wasn't zoonotic. And then so like zoonotic pathogens, they can hide from us. That's what makes them so like interesting and so complicated and just so very problematic. And now I want to kind of jump back to the farm level of agriculture and how zoonotic diseases can be very prominent. A notable disease I want to bring up is it's called foot and mouth disease. Now, what this disease is, it jumps around a lot throughout livestock. So this is the whole farm setting, like cloven-hooved domestic animals. So like we're talking like cattle, sheep, goats, and pigs. The symptoms for them became a little bit more severe. There's a lot of like fever, lameness, and like blisters around in the mouth and the snout and on the feet. Then on lactating females, there were blisters that would break, which would ulcerate. And this would be bad for obviously the mother and then the calf who would be trying to feed. Now, in terms of mortality, it was relatively low. However, there was high incidence rate of this disease. It was very contagious. So a lot of the livestock would fall ill. They wouldn't be wanting to eat, and just productivity would have just this negative snowball effect where loss of profits, people weren't wanting to buy cattle because they wouldn't want their own product to be infected. So this caused marginal losses in money in agriculture. So the virus spread through like direct contact, feces, milk, and it was just able to actually transmit through the air too. Different livestock actually had different roles in this transmission. A lot of the sheep, they remained asymptomatic, but they still carried the virus. Cattle, they were able to transfer direct contact. They became sick and showed a lot of symptoms. But pigs were actually very special. They were able to just excrete far more of the virus to other livestock over like a long period of time. Just every time they would exhale, their respiratory systems would just be able to release like a bunch of the virus into the atmosphere, about like 30 times more than like a cow or a sheep. Actually termed what's called amplifier hosts. And then what these amplifier hosts are able to do is they're just able to replicate this pathogen a lot more, and then of course expel it a lot more into the atmosphere. And then this would have to do with some aspect of their physiology and how their immune system works. It just synergizes so well with the virus, is how it's able to jump around. And then not every zoonotic disease requires an amplifier host, but there are significant infections in humans that do show that. So with all that being said, the whole process of zoonosis, it's very prominent in our lives today, and then in the past, and then of course in the future. This is something that we're going to need to be thinking about, when all this, the whole pandemic right now settles down. We're still not really in the clear from other emerging diseases that could happen throughout this whole process. Just keep an open mind of the possibilities of what we can deal with, and listen to your public health advisors within your community and government, and push towards more public health safety when voting comes around. Look for policies that would help us in the long run to protect us from events like these.